Okay, we're going to work on initial value problems, which deal with antiderivatives or integration. So in this case, when we find an antiderivative and there's a plus c at the end, maybe we're given some extra information so that we can actually find that c value. So as I talked about before, you could have a quadratic that has the exact same shape and the exact same slope throughout its graph, so it has the same, these two graphs have the same derivative, but they're definitely different graphs because they have different heights. So what we're going to do is we're going to be given some value that kind of pinpoints one of these heights, and then we can actually find the c and have a very specific answer. So the problems we have here, the first one, it says if y prime, that's our derivative, if y prime equals 4x cubed plus 2x minus 5, and y of 1 equals 7, that means when x is 1, y is 7, find y, which means the y function. So the first thing we're going to do is we're going to take the function that we have, y prime, and we're going to find the antiderivative. So we'll reverse that process without having to write everything down. But the antiderivative of y prime should be y, and then we're going to backtrack using our power rule across here. So 4x cubed, that exponent will go up to the fourth, and 4 divided by 4 will just knock itself out. And then the next one, 2x, the x will go up to x squared divided by the 2, so there'll be a 1 in front of that. Nice little problem. And the minus 5 will pick up an x, so it'll be minus 5x, and then there's a plus c. Okay, and then what we're going to do is we're going to take this initial condition when y of 1, which the 1 is an x, the output is 7, so that means y is 7. So we'll have 7 equals 1 to the fourth is 1, plus 1 squared is 1, minus 5 times 1, plus c. So if I'm not mistaken, the c here, 7 equals negative 3 plus c, so c is 10. So we'll come back in our finished product. There's a very specific equation is x to the fourth plus x squared minus 5x, and the c was 10, so plus 10. So this has the slope that the derivative says it does, and it also goes through that point x being 1, y being 7. So we got something very specific out of there. Okay. One more example of this initial value problem. Here we have the derivative f prime equals 3 over x and then plus 9x squared. And we're also given that f of 1 equals 6, so that's an xy point, and we're trying to find the actual equation. So let's see here. So we'll take the antiderivative of both sides, so that'll give us f of x equals, this is 3 times 1 over x. So the antiderivative of that would be 3 natural log of x. So we'll have that. And then our 9x squared, the x squared goes up to x cubed, and we'll divide by 3. So 9 divided by 3 is 3. So 3 natural log of x plus 3x cubed plus c. And then we're going to use our xy points. So our x is our 1, and our y is 6. So let's put those in. So we'll have 6 equals 3 times the natural log of 1, plus 3 times 1 cubed is 3, plus c. The natural log of 1 is 0, so that knocks itself out. But it looks like when we clean this up, we'll have c equals 3. So our ending answer is f of x equals 3 natural log of x plus 3x cubed plus 3. Lots of 3's there. I wasn't expecting that many 3's. Okay. So not a hard job if you can find the antiderivative of something.